Today we're going to look at the sum rule for differentiation. This is going to be the simplest of the rules that allow us to combine two functions together. But because it's simple, it allows us to look at the process we're going to have to use to come up with all of our other rules. This is the only one that doesn't have a non-intuitive answer, so you may guess what it is. I still want to go through the process so that you see how we'll apply it later on. When we're doing differentiation, we need to choose between one of our two definitions of the derivatives, either the 2 points coming together or of the distance between the 2 points going to 0. We're going to use the first definition where we have two separate points and we let one point approach another point, and we're going to define our function that we're taking the derivative of as the sum of two other functions. When we combine this together, we get that the derivative of the sum of two functions is the sum of the functions evaluated at the first point minus the sum of the functions evaluated at the second point divided by the difference between the two x values. We can distribute the minus sign and get rid of the outside parentheses on these to get just 4 terms in the numerator, and then rearrange these so that I get all the f's together on one side, all the g's together on the other side, and then separate this into two fractions and also separate out the limits. And when we do this, we see that we get the definition for the derivative of f of x plus the derivative of g of x from the definitions. And so we've rearranged this from one derivative into the sum of two separate derivatives, and this is going to be our final answer. Notice this isn't much of a surprise, but we actually had to use the definitions, go through the algebra to rearrange the terms and show that this was our final answer. So when we're talking about derivatives, if I take the derivative of the sum of two functions, that's the same as taking the sum of the derivatives of those two functions.